Hey guys, it's Miss Lackey. We're going to start off going through some of the basic atomic structure that you learned in Chem 1, so this should be all review stuff. So remember, if you have your pencil, which has graphite, if you cut that into smaller and smaller pieces, the smallest piece you will ever get to is a carbon atom, because graphite is made of carbon. You wouldn't actually be able to physically see it unless you have some type of electron microscope. But remember, atoms are the smallest possible particle that you will have for a substance. And remember, generally atoms are going to be the same. You cannot divide a carbon atom into smaller pieces and it still be carbon. So we're going to look at what the carbon atom is actually made of. So remember, compositions of an atom. We're not going to go through all the history of atomic structure, but remember our atom does have a nucleus. So with nuclear theory, we say that the atom has three basic parts. Most of the atom's mass and all of its positive charge is going to be in the core called the nucleus. So remember, all the protons are in the center in the nucleus. Most of the volume of the atom is empty space. So you have the nucleus and then a bunch of empty space around it. And within that empty space are the tiny negatively charged electrons. And remember that there are just as many negatively charged electrons outside the nucleus as there are positively charged particles inside the nucleus. That way the atom is electrically neutral. And if you remember, we're missing another subatomic particle that you learned about in Chem 1. We're missing our neutrons. So remember, the mass of a neutron is similar to the mass of a proton, but it does not have an electrical charge. They are neutral. So that's why helium has a mass of approximately 4, because it has 2 protons and 2 neutrons in the nucleus. All of that mass is going to be within that helium nucleus. The electrons are so small, they have virtually no mass. Whereas something like hydrogen, which has a mass of approximately 1, is only going to have 1 proton in its nucleus and no neutrons. So remember, looking at all atoms, they're composed of the same subatomic particles. They're protons, neutrons, and electrons. Remember, protons and neutrons have about the same mass, and the electron mass is so small that it doesn't really matter. The mass of an electron is 1 over 8,430th of the mass of a proton neutron. So we say the electrons have no mass, essentially. So remember, when we're looking at elements, elements are defined or identified by their number of protons. So the number of protons in the nucleus of an atom tells you what type of element that atom is. And the number of protons in an atom's nucleus is its atomic number. And we use this whenever we did nuclear chemistry in Chem 1. We use the symbol Z to represent atomic number. So remember, atomic number is going to be on your periodic table. Oh, excuse me, there's 2 of the isotopes. A box on the periodic table, that top number is your atomic number, which is your Z, has your chemical symbol, and then the name. And it isn't shown on this periodic table, but you generally have the average atomic mass located on here as well. And if you notice, no 2 elements on the periodic table have the same atomic number. So no 2 elements are going to have the same number of protons. So each element is identified by a unique atomic number and a unique chemical symbol. Remember, the chemical symbols are either going to be a 1 or 2 letter abbreviation listed directly below the atomic number. Do remember that the first letter is always capitalized, And if there are two letters in the symbol, the second letter is always going to be lowercase. This can especially be really confusing when you have similar substances. Um, so here we have the chemical symbol for helium is capital H lowercase e. Chemical symbol for carbon is a capital C. Chemical symbol for nitrogen is N. This could be confusing for something like copper. Copper is a capital C lowercase u. If you wrote both of them capitalized, it would be carbon and then uranium. So make sure that you are distinguishing between your capital letters and your lowercase letters when writing symbols. With our atoms, we talked about this in Chem 1 as well, we come into isotopes. We're going to talk about isotopes a little bit later this unit, but we want to get through the basics of how you know how many protons, neutrons, and electrons are in a substance. So all atoms of a given element have the same number of protons. However, they don't have to have the same number of neutrons. So remember, isotopes are atoms with the same number of protons. They're the same element, but they have a different number of neutrons, therefore a different mass. And the example given here is neon. Neon has 10 protons, but there are 3 different forms of neon. One with 10 neutrons, one with 11 neutrons, and one with 12 neutrons. They all exist, they just have slightly different masses. So if you remember from Chem 1, we saw isotopes written in 2 ways. We have the isotopic symbol, which is this AZX form. So Z we said was atomic number. A is mass number. And if you remember from Chem 1, mass number is the sum of protons plus neutrons that are located in the nucleus. So the AZX form, it's the mass number over the atomic number with the chemical symbol next to it. So here are the 3 forms of neon that we just mentioned. Neon with 10 neutrons would be neon 20. Neon with 11 neutrons will be neon 21. And neon with 12 neutrons will be neon 22. Notice that all of these have the same symbol and the same atomic number on the bottom. That's one way that you know substances are the same isotope, even if it's not a symbol that you recognize. Another way that you'll see isotopes written is the chemical symbol or chemical name, followed by a dash and the mass number of the isotope. So here we have that same Ne20 or neon 20, Ne21 or neon 21, and neon 22. So either way you see it written, it's still giving you the identity of the element and its mass number. Therefore, you can figure out the number of neutrons. You can also look at these dealing with ions. This was something we did not commonly do in Chem 1. But remember, the number of electrons in a neutral atom is equal to the number of protons in its nucleus. So in a neutral atom, that atomic number is equal to protons and electrons. However, whenever something is going through a chemical change, atoms can gain or lose electrons to become an ion. So we did deal with ions when we did electron configurations, and we looked at how many electrons are gained or lost. So remember, we have positively charged ions like Na plus or sodium that are called cations. Remember that the number of electrons is going to be opposite the sign. So sodium with a positive 1 charge means that we subtracted and lost 1 electron. So the number of electrons would go down by 1. Negatively charged ions such as fluorine or fluoride are called anions. Here F negative 1 means that we gained 1 electron. So it's always the opposite of the charge. A positive means that you lose electrons. A negative means that you gained electrons. Let's work through a couple of these examples together. So here I have 4 different isotopes and ions. Together we're going to go through how many protons there would be, how many neutrons, and how many electrons. So our first sample of silver 109, this is the one where it gives you the name and the mass number. So you would need to look up on the periodic table, what is silver? Silver is number 47 on the periodic table, meaning that we have 47 protons. And excuse me, I'm having to write with my trackpad. It did not tell us this was an ion or had a charge. Therefore, we can assume it's neutral, meaning that the 47 protons should equal 47 electrons. Now, the only thing we have left to figure out are the neutrons. Remember, the mass number, that 109, is protons plus neutrons. So if we subtract them, so 109 minus 47, that means that we have 62 neutrons in this isotope. Let's move on to the next one. This is written in that AZX form. We have 2713, and these would normally be in line on top of each other, but it won't let me type them that way. And this is Al, which is aluminum, and it tells you that it has a positive 3 charge. So this is an aluminum ion. Whenever it's written this way, it's fairly easy to figure out protons and neutrons. So aluminum, it gives us the atomic number is 13. Therefore, there are 13 protons. Remember, neutrons are mass number minus protons, so you simply subtract the top and bottom number. So 27 minus 13 is going to be 14. And remember that this is an ion, so this positive 3 charge means that we lose 3 electrons. So if we do 13 minus 3, this only has 10 electrons. Let's look at the next one. Here we have 5626 Fe, which is iron. There is no charge, so this is an atom, not an ion. So iron is number 26. So there are 26 protons. Because this does not have a charge, there are also 26 electrons. And remember, to find neutrons, we do mass number minus atomic number, so 56 minus 26. And here we have 30 neutrons. Let's look at the last one. Here we have 3216S to the negative 2. So this is the sulfide ion, or sulfur, with a negative 2 charge. So for protons, that atomic number is 16. Neutrons, 32 minus 16 is 16. So here they happen to have the same number of protons and neutrons. And remember electrons. So this negative 2 charge means that we added 2 electrons. So 16 plus 2 is going to give us 18 electrons. Make sure that you try some of the practice problems and let me know if you have trouble with any of these.